So now I will walk you through lab 2, right? So lab 2. So there will be 3 tasks that are essential that you should finish by Thursday. And there are some exercises. And task 5 are optional, right? It's optional. Right? So there are quite some recommended suggested readings over here. Right? So I gave you quite some recommended readings. You don't have to read everything, right? So, but these are more like good references. So you treat it more like references, right? So for these two, right? So you should take a look, right? So at least you should really click it and open and see what's over there, right? So these are all very good references, right? So very good references, and you will frequently use, right? So in your during the module, right? During the module. There are also some cheat sheets, right? So I have collected that will be very handy, right? So these will be very handy that you please click, right? So you can click, you can click, right? Whatever you see, there's a hyperlink, right? You can click, and these are some very handy references, right? You can those are frequently used commands, right? So that it will be very helpful for you. Right, so here's a recommend tip, right? So that you should try to use as much DataFrame APIs as possible, right? So for how to learn from that, right? So I can't teach you every API, right? So, but you should really refer to the documentation, right, to learn. And there are also some pointers in the slides, right? So hyperlinks, right? So that's my suggestion, right? So when you try to program something, try to search, right? So where there's a function already, right? So typically for all our tasks, right? So there should be some API already. You should try to use the existing APIs, right? So the first section is about RDD and shared variable, right? So that's the two main abstractions in the Spark. And to start, right, this will be something that you will do a lot, right? So this is when you log in, right? So when you log in your HPC, this is what you need to do, right? But this time, you need to install Numpy, right? So for task 3, right? I just found that task 3, you need to install Numpy. You need to activate your environment and install Numpy, right? So you need to please follow here, right? So here, this time, I request 4 cores, right? 4 cores. Therefore, your PySpark can also start with 4 cores in the interactive mode, right? So, right, so that's here is a very brief introduction to RDD, right? I also make some changes, right? So like this is something, right? So from lab 2, right? So I will show the output as comments, right? So this will be easy for you to copy, right? You can just copy the code, Control C, and paste in the terminal in your PySpark shell, right, to run the code. So I will show the output on my account, on my HPC after a hash, right? So show it as a comment, right? So if you see the result like this, right, that means it's correct. Right? That means it's correct. Of course, for those random results, right, you should know that as long as it's close, right, it should be fine. Right, so you can specify this is you can set, right? You can set the number of partitions, right? Set the number of partitions. For example, here I set to 16, and this will be the output, right? You see, right? So you see it's still Scala, right? It's still use Scala because it's built on Scala, right? So it's built on Scala. Although we are using PySpark, but the core, right? So the underneath code is still Scala, right? So right, so this is a general rule, right? So the general, if you do not specify, right? If you do not specify this number, Spark will automatically set it, right? So I think the rule is basically 2 to 4 partitions for every CPU, right? So every CPU in the cluster. Right, so this is a very classic problem of pi estimation, right? So this is if you want to know if you cannot understand why it works, right, please click this link to see how it works, right? So basically, this is trying to estimate pi by throwing dots, right, by randomly sampling within a unit circle, right? So this is the code, right? This is a code. This is a typical example. And you should get something like a 3.14 blah, blah, right? So this is something that you should be able to obtain, right? So you can just copy the code and paste in your shell, right? So, and then for shared variables, right? I think, as I said in the lecture, this will be more relevant when we work on a node, right? Work on a cluster, right? So that's not our case, because in our case, we are, although we're working on the HPC cluster, right? So, but mostly we are using local, right? So we are using local rather than cloud, right? Using local cores, right? So therefore, it has less problem, right? So this is a very briefly introduce the broadcast. But this is just in the future, right? So if you need it, right, you know, like where to find it, right? You know something about it. If you are curious about data serialization, right, so you can click this to learn more. And this is a very brief introduction of accumulator. Right? That's just to introduce what it is, right? So, but it's actually to use it well, right? So it's a little bit complicated, right? So you can click in and learn it, right? So you can click in over there and learn more, right? So if you're interested. So section 2 will be about the data frame, right? So data frame. Talk about transformations, right? So here is a creation of the RDD, right? Creation of data RDD, and then convert the RDD to data frame, right? To data frame. And now you can see, right? So this is a data frame that you can see, right? So that's basically a table, as we said, more like a table. And but it's typed, right? So there's a type, right? So you can infer the type if you print the schema, right? You should do this a lot, right? So to print the schema to see it. You can also get RDD from data frame. I will show you how. And then next we are going to load data, right? So from a CSV file, right? So that is create a data frame from an external file, CSV file. And this is if you show it, right? So this is what you see, right? So that's advertising data, advertising data. And you will see a warning, right? You will see a warning over here. That's warn. Header does not conform to the schema, right? So this is because here, right? So it's empty, right? If you open the CSV file, you will see this field is empty, right? So therefore, there's a warning. It's not an error, it is a warning, right? So therefore, Spark just fill in, right? Just see column 0, right? So this is a dummy, right? It's more like a dummy header, right? So dummy header. You can modify, right? I have tried, right? You can modify the CSV file by manually specify the header, right? So then this warning will disappear. Right? So you can print the schema, right? You can infer the type, right? Infer the type from there. It's being inferred, right? These are all inferred. Right? Some operation, remove some, right? So this is a very useful useful summary, right? You can describe to get some summary, get the count, mean, standard deviation, mean, and max, right? It's very useful function, right? A very useful function to describe it, right? So then the third task is about machine learning library and pipelines, right? These are all from the official documentation covered in the lecture as well. Right, so this is a estimator. This is an example of linear regression on the advertising, right? Advertising task, right? Right, so you can read in the data. Your data is already reading, right? So in the previous task 2, right? Task 2. So here the feature, you can see the features. the label, right? So this is a feature and the label. These are regression tasks, right? A regression task. And you do the random splitting to have the training and test sets. Right? So you can see, inspect it. Right? So now this is what we are saying, right? So when you create new RDD, a new data frame, right? It's just append, right? You just append, right? So for example, here, that's a feature. This is label, and that is a prediction, right? That is a prediction. You just show over here, right? So that show here. You can compare, right? So the result actually is not that good, right? For this one is very off, right? This one not too bad. This one is bad, right? So and it also shows how you can evaluate, right? So evaluate the error, and this one error is quite big, right? Quite big, 1.9 something. But actually, compared to here, right? It's not too bad, right? It's like a 2, right? So your error is not too bad, right? This one is very bad, right? So 10. This is the error on the whole data set, right? On the whole data set. This is another example of a machine learning pipeline, right? So I think we didn't use pipeline, right? We didn't use pipeline over here. So here is an example of a pipeline, right? So this is the same as the one in the lecture, right? So it's one same as you define the pipeline over here, then you fit the model, right? So this is your test data. And then you use a model as a transformer, right? So to transform, right? So your input to obtain the prediction, right? So therefore, if you show it, right? If you show it, you can see all the data frame, right? The ID, is a text, right? So after tokenizer, you have words, and then after the hashing, right? You have features, and this will be your raw prediction, and this will be the probability, because we are doing logistic regression, right? So then that is your final prediction, right? So by basically by binarizing it, right? So binarizing it, right? You can also select the field, right? So to show some useful manipulations, right? So that's all. Then the exercise, you can continue work on some of the local mining problems, right? So try to learn how to download data using wget from the on the HPC. And this is a variation of what you have done in your lab, right? It's just to check whether you have understand what is covered in the lab, right? So these are some exercises, okay? There are many other examples that you can explore if you like, okay? So that's all. That's all about week 2. And from the next week, right? From the next week, we will start to talk about one scalable machine learning algorithm each week, right? So these first 2 weeks are more for fundamentals and foundations, right? Therefore, we talk about Spark, we talk about PySpark, we talk about RDD data frame pipeline, execution, right? So these 2 weeks are the foundation, right? So, and from next week, we will talk about the scalable machine learning algorithms, right? So I will see you in the next video, right? So, and also in the online sessions. Okay, bye-bye.